So for 3.6 geometric sequence practice number 2, which is our review for the assessment, on slide number 3, it's just what are some similarities, what are some differences. So just kind of want you guys to think about both of them involve the common ratio, because we are talking about geometric in this case. You can use the important words a sub n, which is the nth term. So both are trying to find whatever term we're looking for. Explicit tells you what term you're looking for. So if it says find the 12th term, that's going to be your n. Where recursive is trying to find the next term using the previous term. So that could be a difference. Because inside the parenthesis, it's the previous term multiplied by the ratio. Where in explicit, it is the first term times, or the first term parentheses the ratio raised to whatever you're looking for minus 1, which we'll go in depth later on. Now for number 4, a sub 1 is just the first value of the sequence. So in the first sequence, it's 324, because that's the first term I see. Now when you have to work backwards, that's when you're trying to find the ratio. The ratio is 4 divided by 12, 12 divided by 36, 36 divided by 108, 108 divided by 324. Now the reason why I know that I'm dividing right away is because I'm telling you it's a geometric. So we don't have to find if it's the arithmetic or it's geometric. I'm telling you it is geometric. So find the common ratio, which is 1 over 3. And you're going to do that process over and over again. So for this sequence, the first term is 110. I'm going to go to my calculator and I'm going to start from behind. The 880 divided by the 440. And that common ratio is going to be 2. Now in this geometric sequence, we're going to begin with 2. And then if I plug in to find the ratio, I'm going to get the ratio of 4. So slide 5 and 6 are different. It's like fill in the blank. We're going to use the following sequence to answer the question. So we have to determine if it's geometric or arithmetic, or arithmetic, okay? So how we do that is I recommend starting with the common difference first. If you minus the 2, we're going to start from behind again. You're going to minus the 2, and you're getting the same number. Keep going. Keep going until you're either done or you get a different number. In this case, we got a 12. So that is saying that this is arithmetic, because it has a common difference. How do we know it's different? Because we minused and we got the same number of 12. So that's all we were looking for there. So I'm going to click these boxes, and those are the numbers and terms that we used. Now common difference always goes with that type of sequence. However, look at slide 6, where some of you are struggling with slide 6 is it's fractions and you don't know really how to put it in the calculator correctly. So make sure that you hit the division bar first and then use parentheses. Before you do that though, you should see if the difference works. So I always like to start with the difference. You go until it's a different number or you run out of terms to subtract. In this case, they're different numbers. we found the first difference to be 3.375, and then the second difference is 2.25. So it's not the arithmetic sequence. There is no common difference. So then that is where I'm going to say, try to divide. I'm going to use parentheses. The more you do it, the easier it's going to become. All right, I got 1.5. I'm going to hit the fraction bar again, and then I'm just going to keep going until I am done with numbers. Notice I'm getting 1.5. This is looking really good, guys. 9 divided by 2. Make sure you type it right. That's where the big mistakes are. And then finally, 3 divided by 2. Look at what happened. We have a common number. We have 1.5, 1.5, 1.5, 1.5. How did we get that? We did that by creating a ratio. So whenever you have a common ratio, let me just type it right here, and say what that common ratio is. We know that that is actually a geometric sequence. So whenever you have a ratio, it is geometric. All right, move on to slide number 7. So whenever it says explicit or recursive, if you're not sure what that looks like, move back to slide 3. Slide 3 said, okay, it's a sub n equals a sub 1 parentheses 1 raised to the n minus 1 power. So I'm just going to write that down. And then I'm going to use this information to help me. So the only work that you need to do for this one is initial value, which is 25, and then the common ratio, which is 1.5. So just label it. Our initial value is a sub 1, and then an r is 1.8. So then you just put that all together. So a sub n equals the 25 with the, I'm sorry, it's not the rate, it's a common ratio inside the parentheses, n to the minus 1. And then make sure that you are picking the correct one. Now for the error analysis, Ali just switched them, okay? So a sub 1 is 3, so it should go outside of the parentheses. So it should technically look like this. And then the common ratio goes inside. So you can write that he switched them. Write a sentence, do what you need to, but use slide 3 to help you as well. Because this is explicit formula. In explicit formula, the a sub 1 goes outside the parentheses. The common ratio goes inside the parentheses. For number 9, we're talking about the recursive. Once again, you can go to the third slide if you need to know what that is. So this time, the ratio goes on the outside. We're talking about the previous term on the inside. And then you have to tell your reader what is a sub 1. So we said a sub 1 is 6. We said that the common ratio was 10. So then all you have to do is piece it together. Our ratio for recursive goes on the outside. Our previous term goes on the inside of the parenthesis, and then tell the reader where you start. So a sub 1 is going to be 6. So carefully match that up. And then it goes like that. For number 10, we're going to use the explicit formula, and so is number 11. Explicit, our a sub 1, we said was 360 because that's our starting term. use your calculator to find the ratio. So 22.5 divided by 45, and then you keep going. So once you have the common ratio, that's going to be your R value. So your R is 0.5, or you can make it a fraction, does not matter. And then you put it into the formula. So A sub n equals our A value, which is 360, parentheses, and then be careful here. You want the n minus 1 here. So just match that up to the problem on slide 10. Step 2 is where students get a little confused because it says the 9th term. Well, what does the 9 mean? The 9 means the n value. So that's the term we're looking for. So you want to plug that 9 into the exponent. Remember, you have that 9 minus 1, so you have to make sure that you do that. Once you do that, that is what goes into the calculator. So 9 minus 1 gets you an exponent of 8, and then you just type in, no rounding this time. You could put it as a fraction too, it does not matter. And then you're going to do the exact same thing for slide 11. So slide 11 says the starting term, our initial value, is 3072. I'm going to work backwards to find the common ratio. Notice it's common, so our R equals either 0.25 or 1 over 4. Either way, totally fine. And then you're going to put that all together. So our A sub n, our nth term, is going to be our beginning value with our ratio in the parentheses raised to the n minus 1. So here it says find the nth term, or the 7th term, which is our nth term. So then we're going to plug that in. So 7, and then put the 1. So 7 minus 1 in the exponent is going to be 6. And then use the calculator. Once again, use the Desmos calculator so then I can see any calculations that you do. So you can keep it as a decimal, 0.75, or 3/4. 3 divided by 4 would have gotten you the same answer. So like always, if you have any specific questions, let me know. Hope you guys did well on this. Thank you.